Alright, so this is what's it called? Yeah, this is 3.3 and chapter 4.1 to 4.2 grids and tops. Alright, we're gonna fly through this. Alright, so we're gonna start with the grids here. Chapter 4. If you see, she included it in the material now, 4.1. So we're gonna do those as well. Alright, so let's start. Question 31. I'm gonna just take to the idea. They gave you a parametric equation, radical t and t squared for the y. What they're saying, the second derivative is equal to kt, where k is a whole number to be determined. What is the value of k? أول شيء, for the parametric equation, you need to know two things. The first thing is the first derivative of the parametric equation, dy by dx. To find the first derivative, it's equal to y dot over x dot. Alright, what's y dot, what's x dot? But y dot is basically the derivative with respect to time. So the derivative that's given to you over here. Alright, so let's find out what's y dot. It's just the derivative over here, which is 2t. What's x dot? It's equal to 1 over 2 radical t. Why? Because the derivative of t squared is 2t. The derivative of radical t is 1 over 2 radical t. I'm not going to show you why. You're grade 12, you should know how to derive. Okay? Anyways, 12S, not 12 in general. So anyways, so what's dy over dx going to be? It's just going to be 2t over 1 over 2 radical t. Now, over means you're going to take this guy up. So it's going to be 2t times 2 radical t. So it's going to be 4t radical t. Nice. So this is dy by dx. Okay. Now, do you need this for this question? Not really. What do they want? They want d squared y over dx squared. Alright? The second derivative, which is given by d squared y by dx squared, which this is called y prime here. This is called y double prime. Okay? Its formula is x dot... Sorry, its formula is y double dot x dot minus x double dot y dot over x dot cubed. Alright, this is basically the quotient rule of this, right? U prime, so y dot becomes y double dot, and then v, which is just x dot, minus v prime, which is x double dot, u is just y dot, all over x dot. But instead of squared, it's cubed. That's the special case for a parametric equation. Anyway, so applying this, y double dot x dot. So what's the second derivative? This is y dot. What's the second derivative? It would just be 2, right? Deriving this a second time will get you y double dot is 2. Deriving this a second time will get you... It's a pretty tough one to derive quickly in your head. So let's do it. The second derivative would be 1 over 2 times 1 over radical t. Take the radical t up, so it's going to be 1 over 2 t to the power of minus half. So multiply it there, so it's going to become minus 1 over 4. Because half times half is 1 over 4, and then minus, so minus 1 over 4. And then t, subtract 1 is going to become 3 over 2. So t to the power of 3, like this. Okay, which is the same as minus 1 over 4 t radical t. Anyways, this is x double dot. So we now know x double dot, which is this. This is y double dot. This is x dot. Well, this is y dot. Let's substitute into our formula. Y double dot, so 2. X dot is 1 over 2 radical t. Minus x double dot, so this. I'm just going to make it plus because minus. So I'm just going to make it a plus. 1 over 4 t radical t. And then y dot, which is 2t. Alright, all over x dot cubed, so 1 over 2 radical t cubed. Alright, let's see what can cancel. We can cancel this t and t. Cancel this 2 and 4. It's going to become... Here you're going to have this 2 that you can cancel. It's... Actually, yeah, let's just cancel it. Because I don't think you're going to get the idea to do something else. So you're going to get... Here you're going to have the 2, because we canceled 4 and 2, the 2 will stay. Alright, so plus 1 over 2 radical t all over 1 over 2 radical t cubed. Alright, we can make this common denominator if we multiply by 2 and 2. So we're going to get 2 plus 1 over 2 radical t all over 1 over 2 radical t cubed. Now, basically, this 2 radical t and this... hold up. Yeah. I was saying انه I had to look here, but this is useless اصلا. I tried to see if I can benefit. But yeah, we stopped here. Let me just simplify this, make it look a bit cleaner. So 3 over 2 radical t all over 1 over 2 radical t, and this is cube. Now basically, distribute the cube inside, you're gonna get this. Everyone has their own way to solve. You can حتى without distributing, خلاص you get this. Some people say fraction divided by fraction, so they write it like this. They multiply the these ones together and these ones together. كيفك يعني, whatever you want. But the easiest way to do it, let's say you're lost, it's like saying this fraction divided by this fraction, right? So this divided by this. And you guys know when you're dividing a fraction, you just flip it, so it becomes like this. This is cubed, this is cubed. Now you can cancel this with this, it becomes square. So you're gonna be left with 3 times, what's 2 radical t squared? It's gonna become 4t over 1, so it's gonna become 12t. Alright, the math part of this is pretty annoying. You have to solve it, it's a bit long. Alright, anyway, so this is the answer. So what's the answer? K is 12. This came in the exam before, by the way, last year. Alright, so just make sure you know it. Alright, in chapter here you don't have much, there's the t's, 33 and 34, so let's do them. Okay, let f of x equal, let me scroll up a bit. Let f of x equal root 1 minus cos x. What's the domain? What's the domain of the derivative? We'll write the equation of the line normal. Is Rolle's theorem applicable? So this is actually a very easy question. I hope this comes in the written. It's very easy. Alright, what's the domain of f of x? Now, cosine has a domain that's all real numbers, but the problem is here it's under a radical. And you guys know when you have something under a radical, it can't be negative. So this is from grade 8. You set what's under the radical to be greater than or equal to 0. So that means you take 1 to the other side, you're gonna get negative cos x greater than or equal to negative 1. Dividing by the negative on both sides, you're gonna get cos x less than or equal to 1. Now this is true. You can like do shift cosine and try to get to whatever, on radians of course, and you're gonna get that x is equal to 0 and x is equal to, what's it called, that's it, 2 pi. You can say 2 pi also, so that doesn't matter. So my point is, this is always true. Alright, this is always true. You don't have to solve it. Like you don't have to get the solutions. You can just say always true. Why? لأنه you know that cosine x is always in between 1 and negative 1. Right? So always, it's always gonna be less than or equal to 1. Okay, anyways, so if you get it in your written part, just write it like this, and get this and say it's always true, because you don't have to say the because. If you just put always true, you should get the mark. But if you want to be fancy, because cosine x is always in between, it has to be with the equal. Huh? If you write this, it's gonna be wrong. It has to be with the equal sign. Okay, 1 and negative 1. Anyways, what's the domain of f prime of x? So we have to derive this and see basically what we get. Now the derivative of this is going to be 1 over 2 radical 1 minus cos x times sine x. Now how do I get that derivative? Basically I have memorized that radical of any u, the derivative of it will always be 1 over 2 radical u times u prime. Okay, no, I just have it memorized as Syria. Now you can do it the old way, which is completely fine yani. Okay, 1 minus cos x to the power of half. Multiply the half down, you get half 1 minus cos x to the power of negative half. And since you have to, it's a you know, there's a function inside, you have to multiply by the derivative, which is what? What's the derivative of 1? 0. What's the derivative of negative cosine? The derivative of cosine is negative sign. But since it's negative cosine, so you have to put negative, and the derivative of cosine is negative sign, so it just becomes negative becomes positive. Right? So we're just going to do that. Okay, and basically it becomes, since negative power, you take it down, so it's going to become 1 over 2. Since it's a fraction, so it's going to become radical. And this is basically this is the derivative. Okay, nice. So they're saying what's the domain? What's the domain of this function? You have to make sure that this denominator is never equal to 0, right? Well, since it's a radical command, you have to make sure that this denominator is always greater than is never negative. So you have to check that it's never 0. It can never be 0. Will never be less than 0. So what's the case? You have to set this denominator. If it can't be 0, it can't be less than 0. You set it greater than 0. It has to be greater than 0. So you say 2 radical 1 minus cos x greater than 0. Sorry, not 2 radical 1 minus cos x. You only set what's inside 1 minus cos x to be greater than 0. You don't care about the outside or the radical or anything. We set what's inside always. If you have a radical, set what's inside. Anyways, following the same steps as here, 1 to the other side. Never move cosine x, okay? When you're working with an expression like this, you're never allowed to move the x term, okay? Never. Tamam? Anyways, you're gonna get that 1 to the other side. You're gonna get negative cosine x greater than negative 1, so you're gonna get cosine x less than 1. Type 1 is cosine x less than 1. We agreed up that cosine x is always in between negative 1 and 1. Alright, so this should be true. This is true always. Except for what? It's always true. Here we're not saying less than or equal, we're saying strictly less than 1. So what do? You have to check 1 is cosine x equal to 1. So 1 is cosine x equal to 1. You do shift cosine. You're gonna get that x is equal to 0 or 2 pi. Okay, so this is always true except for x is equal to 2 pi k. Why 2 pi k? Why am I saying 2 pi k? لأنه it can be يعني مثلا 2 pi, also 4 pi, 6 pi, 8 pi, you know, because they didn't give us a certain domain, they didn't give us a certain interval. You know how cosine repeats itself every 2 pi? Always you have to put that extra 2 pi, okay? Sorry, the 2 pi times k. K is the number of revolutions, right? You can say, if you want, instead of that, you can just say, hey, instead of putting the 2 pi, you can just say x equals 0, because the calculator will give you 0, okay? X equals 0 plus 2 pi k, okay? This is the domain. So what would the domain be? Also here, I didn't write the proper domain. Since this was always true, that means all real numbers or all are. Okay, this is, I should have written that because they asked for the domain, so you need to say all real numbers. Then here, what's the domain of f prime of x? You say all real numbers except 0 plus 2 pi k. X is equal to 0 plus 2 pi k, where you have to say that where k is an integer. Yani, what do I mean when k is an integer? Yani, k can't be 1.5, k can't be 0.7, it can't be any decimal, it has to be an integer, yani, it has to be a whole number. Okay, this is very easy. حتى يعني they gave it to you here. K belongs to z, yani z means integers, all natural integers. Alright, so anyway, this is gonna be very easy. Yani, شو بدي لك. So far, part A, part B, easy. Okay, then they said write the equation of the line normal to the curve x equals pi over 2. To do this, wait, before I continue, for part A, this is all you have to write, okay? For part B, you just derive it, you get this, and you say this has to be greater than 0, okay? Solve, show this, and you say that's always true except for when do shift cosine 1, you're gonna get 0, okay? And you say 0 plus, always add the 2 pi k, or 2k pi, whatever. So you say that the domain is all real numbers except x equals 0 plus 2 pi k, where k is an integer. That's it. Anyways, same thing for part A. You say always true, whatever, because this is this, and then you say that the domain is all R. Part C, write the equation of the line normal to the curve at x equals pi over 2. To write the equation of the line normal to the curve, we need the slope, right? Y is equal to mx plus b. We need the slope. So how do we find the slope? Don't we have the normal? Sorry, don't we have the derivative? Yes. So let's substitute. Substituting this into the derivative will get you what? Will get you the slope of the tangent. So let's first find the slope of the tangent. M of the tangent will be equal to the value of the derivative at x is equal to pi over 2, right? So it's gonna be equal to sine pi over 2 over 2 into radical 1 minus cosine pi over 2, which you're gonna get as 1 over 2. Okay, and this is 0, 1, 1, 2, radical 1, 2 times 1, you have 1 over 2. Yeah, 1 over 2. Type, do we want tangent or normal? We want normal. So what do we do? M normal is going to be equal to -1 over M tangent. So it's going to be -2. So we know it's y is equal to -2x plus b. Do we have any point that we can try? No, not really. So what do we do to try at the point? We only have the x coordinate. We don't have its y. How do we find the y? We just throw it into here to figure out the point. So what's the y value of x equals pi over 2? Throw it up there. So let's find what's f of pi over 2. It's equal to radical 1 minus cosine pi over 2, which is equal to 1. So the point we're going to test now is what? Pi over 2, which is the x, comma, what's its y? 1. Let's test it out into here. So 1 is equal to -2 pi over 2 plus b, cancellation for the nation. So you're going to get b is equal to 1 plus pi. Alright, so what's the equation of the normal going to be? Minus 2x plus 1 plus pi. I hope that's the answer. They want it like this. This is the same answer as this, by the way, huh? Minus 2x plus 1 plus pi. I'll prove to you why. Distribute this here. You're going to get y is equal to minus 2x plus pi plus 1. Why? When I plus 1, I moved it to the right, why I distributed this. Okay? Which is the same thing, huh? Anyways. If you want, put minus 2x and then put plus 1 plus pi under the brackets. It doesn't make a huge difference, but it shows the person correcting your paper that this is the b value. Alright? Anyways, شو بعدهم part D هلا. Is Rolle's theorem applicable? For Rolle's theorem to be applicable, it's so easy. First condition, f of a must be equal to f of b. Second condition, it's continuous. Third condition, differentiable. أول شيء is f of a equal to f of b. What do you check? What's f of a, f of b? يعني f of this must be equal to f of this. Let's check. F of pi over 2, is it equal to f of 3 pi over 2? Let's check. F of pi over 2, we found it to be 1. Substituting 3 pi over 2, 1 minus cosine 3 pi over 2 also will get you 1. So this is 1, this is 1, so they're equal. So first condition, done. Second condition, is it continuous over this interval? Let's check. This is the, this is the function here. Right? Radical 1 minus cosine x. اتفقنا انه its domain is all real numbers. So is it continuous? Absolutely. No reason for it not to be continuous. Alright? So it's continuous. Tick. F of a equal f of b ticked. The last one, is it differentiable? It's radical 1 minus cosine x. Do you see absolute value? No. Do you see any, I don't know, when would it not be differentiable? Do you see any piecewise function? No. It's just one polynomial, trigonometric polynomial. So easy. So since there's no absolute value, there's nothing. It's differentiable. No reason for it not to be differentiable. So what do you write? Actually, you show that this is equal. Then you say it's continuous, since the domain is all real numbers. Okay. No need to say that. Just say it's continuous, and then you say it's differentiable, and you're gonna get the full mark. So see, it's continuous, it's differentiable, and this is equal to this. Alright, this is literally all you need to write. You don't even have to say it equals 1. Alright, question 34, I think, is the last top question for this chapter. I'll do it quickly. Where is the material? Question 34, let's do it. Okay, the equation of a curve, this is easy, is cosine 2x sine x. I'll find the derivative, or then find the x coordinate of the stationary point. This is so easy. Find the derivative. This is product rule, because there's two being multiplied by each other, so we use u prime v plus v prime u. And now what I like saying is u is equal to cosine 2x. So what's u prime? U prime would be equal to negative sine, so negative 2 sine 2x. Why? Because the derivative of cosine is negative sine, and you derive what's inside as well. Multiply by the derivative of what's inside. So what's the derivative of x? Sorry, the derivative of 2x? It's 2, so you multiply by 2. So negative cosine 2x times the 2 will become negative 2 sine 2x. I'm teaching you how to derive. I mean, it's v is equal to شو sine x. So v prime is cos x. So degree, let's just do it. U prime v, so it's gonna be negative 2 sine 2x sine x plus v prime u, so cos x cosine 2x. Alright, and then they said part B, find the x coordinate of the stationary point. This is done, right? That's it. And I'm taking a look at the solution. Yeah, look, they added another question. Yeah, guys, so I'm looking at the solution. I don't know where they got this question from as question 34. This is the question 34. This is the equation that we got. So easy. Then they said find the x coordinate of the stationary point. And what do? We equate this to 0, yeah? So easy. Now, solving this is a bit tricky. I actually had to look over the solution to check. But yeah, let's do it. So we're equating this to 0. Basically what they did is they expanded sine to x and cosine to x into, if you remember, sine to x is 2 sine x cosine x, and then sine x. Alright, plus cosine x, cosine 2x, I'm gonna write these on the side. Sine 2x is 2 sine x cosine x. Cosine 2x is 1 minus 2 sine squared x. Alright, so here they put 1 minus 2 sine squared x equals 0. Now what do? They factor out this cosine because it's common in both. Okay, so they factor it out. It would become cosine x minus 2. I'm gonna change this into minus 4. Minus 4 sine squared x. Lay sine squared because sine x, huh? And this is minus 4. Alright, plus this cosine x went out, so 1 minus 2, this cosine x outside, huh? 1 minus 2 sine squared x equals 0. So we got two solutions. We got that this thing equals 0 or this thing equals 0. If cosine x equals 0, do shift cosine, you're gonna get that x is equal to pi over 2. And pi over 2 is not included in the interval. It's outside the interval. X is strictly less than pi over 2, so no solution. You say not in domain or whatever, interval or whatever. You say rejected. Then you look at the one inside. Let's equate this to 0. 1 minus 4 sine squared x plus 1 minus 2 sine squared x. This 1 it becomes 2, it becomes 6. 2 minus 6 sine squared x equals 0. Take this other side, you get sine squared x is equal to 1 over 3, because you took it to the other side, divided by the 6, and then you're gonna radical both sides. You're gonna get that sine x is equal to plus minus radical 1 over 3. Now since sine x has to be since x has to be between 0 and pi over 2, we're not gonna take the negative root. Okay, you say since x is in between what's it called? Yeah, since x is in between 0 and pi over 2, only sine x is equal to radical 1 over 3. And then doing shift sign, you're gonna get x is equal to sine inverse radical 1 over 3, which equals, I don't know, I actually have no idea. ليه كيف جايبوا 6 1 over radical 6 كيف هيدي بتصير minus 6. hold up. Hey guys, I'm looking back over my solution. من وين جبت أنا هيدي this one? I thought this is a parentheses, or I thought it was 1. let me erase that. This just becomes 1. هيدي بتصير, that means when you take it to the other side and flip it, it's gonna come over 6, huh? Alright, if I just set over 6, and you get the sine inverse of 1 over 6. Radical 1 over 6. And you get 0.42, is that correct? Yeah, 0.42. To 3 significant figures, 41 أكيد. Alright, that's it here. Chapter 3.3 done. Thank you so much for watching. Good luck.